geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A spring of force constant K is cut into lengths of ratio 1 is to 2 is to 3. They are connected in series and the new force of constant K dash, if now they are connected in parallel and force constant is K double dash, then what is the relation between the K dash and K double dash? There are three springs. One arrangement is series arrangement. With the series arrangement, equivalent force constant is K dash. Then it is arranged in parallel to have the equivalent force constant K double dash. You are asked to decide what is the ratio between the K dash and K double dash. For that, first let us take the series arrangement. For series arrangement, for the series arrangement, 1 by equivalent force constant K dash equal to 1 by K1 plus 1 by K2 plus 1 by K3 is equal to 1 by K dash equal to 1 by K1. Here look at the K1 value. K1 equal to 1, K2 equal to 2, K3 equal to 3, 1 by 1 plus 1 by 2 plus 1 by 3. Let us simplify it. 1 by K dash equal to, this is K dash. 1 by K dash equal to 1 by K dash equal to 1 by 1, 1 plus, right, 1 by 2. 1 by 2 is 0.5. Otherwise, let us take LCM. Let us take LCM. It can be written as 6. 6. It is 6 plus 3 plus 2. It is equal to 11 by 6. 11 by 6. From this, okay, 1 by K dash equal 11 by 6. Then K dash equal to 6 by 11. Okay. Similarly, let us take the parallel arrangement. For parallel arrangement, for the parallel arrangement, equivalent force constant K double dash equal to K1 plus K2 plus K3. It is equal to 1 plus 2 plus 3 equal to 6. Then K dash by K double dash equal to K dash, we got 6 by 11. 6 by 11 divided by 6. 6 6 cancel. K dash by K double dash equal to 1 by 11. Therefore, K dash is to K2 dash. K dash is to K double dash. K double dash is equal to 1 is to 11. That is the answer. Look at the options. Look at the options. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem asking like this. In the given figure, acceleration A is given 15 meter per second square, represents the total acceleration of a particle moving in the clockwise direction in a circle of radius r. Look at the direction of motion of the particle. This is your particle. That particle is rotating in the clockwise direction. Okay. Now radius of rotation r is given 2.5 meters at a given instant of time. The speed of the particle is. Okay. As you know, here centripetal acceleration A must be equal to v square by r. It must be balanced by, the centripetal acceleration must be balanced by resultant of radial component of velocity. Let me write that point. this centripetal force, centripetal acceleration, centripetal acceleration must be balanced by resultant of resultant of radial component of velocity. Radial component of velocity. Radial component. Let me write clearly. Radial component of velocity. Component of velocity. Resultant of radial component of velocity, that is a cos theta, that is 30 degrees. That means this v square by r must be equal to a cos theta. Okay, right? What it is asking? You're asked to decide what is uh, the speed of the particle. What is the velocity? Here v square equal to a r cos theta, or v equal to root over a into r into cos theta. It is equal to root over a value. Look at the a value, 15. R is 2.5. 15, 2.5 into cos 30, 1 by 2. It is equal to root over uh, root over 15 into 2.5 divided by 2. You simplify this value for getting approximately 5.7 meter per second. That is the speed we need to maintain. 5.7 meter per second. Option C is absolutely correct. Are you following clearly? Yes. Similarly, let us take the another important problem. It is asking like this. A particle of mass 10 grams moves along a circle of radius 6.4 centimeters. Mass of the particle m is given 10 grams. The radius of rotation of the circular motion 6.4 centimeters. It is equal to 6.4 into 10 power minus 2 meters. Similarly, mass equal to 0.01 kilograms, 10 by 100. With a constant tangential acceleration. Here, tangential acceleration, let that is at equal to r alpha, it is remaining constant, given clearly, remaining constant. Okay, what is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to 8 into 10 power 4? Kinetic energy Ke equal to 8 into 10 power minus 4 joules by the end of the second revolution after beginning of the motion. As you know, the kinetic energy Ke equal to half into m into v square. V equal to what? In terms of angular velocity, r times the omega. Then kinetic energy Ke equal to half into m into v equal to what? R omega whole square. So kinetic energy equal to half into m into r square into omega square. So you're asked to decide uh, what is uh, the acceleration. If the okay, you're asked to decide acceleration. This actually constant tangential acceleration you're asked to decide. Now from this, okay, as you know, it is given tangential acceleration equal to some alpha into r. From this alpha equal to what? Tangential acceleration divided by r. As you know, one of the equations of motion for circular motion is omega square minus omega naught square equal to 2 into alpha into theta. Right? It is asking what is the acceleration after completing the second evolution from the beginning. From the beginning means here omega naught equal to 0. Finally, omega square equal to 2 into alpha into theta. The theta equal to 4 times the pi because it is asking what is the angular speed maintained by the what is the acceleration maintained by the particle after completing the second revolution. Okay. Now here it is omega square equal to 2 into alpha into theta. Theta 4 pi. 4 pi. Of course, in the place of alpha, I can write the tangential acceleration divided by r. Tangential acceleration divided by r. It may be small r or capital R. Okay. That is omega square value. So kinetic energy equal to, okay, kinetic energy K equal to, what is the kinetic energy? 6.4 into 10 power minus 2. 6.4 into 10 power minus 2 equal to half into mass. Look at the mass. Mass is 0.01 kg. 0.01 kg into r square. R square can be written as 1 minute. R square, let it be as it is, because omega square is having in terms of radius. It is 2 times the what tangential acceleration divided by r into 4 into pi. Yes. Here 1 r will be cancelled. 1 r is cancelled. Finally, it is 6.4 into 10 power minus 2 equal to 0.01 divided by 2 into radius. Look at the radius. 6.4 into 10 power minus 2. 6.4 into 10 power minus 2 into constant tangential acceleration 4 into pi. From this, you can decide constant tangential acceleration. You simplify this value for getting around zero point 0.1 meter per second square. 0.1 meter per second square, approximately. Okay, that is the answer. Look at the option C. Option C is absolutely correct. Understood clearly? Yes.
Geobyte.